Now I'm working page 471. Try these A. This is problem B. Okay, I wanted to start with this one, and then I'm going to have you try problem A in a few minutes once we're done with this one. But I wanted to start with this one because the previous example that I showed you, the quadratic was set equal to 0 when we first started. This one is not, okay? So the very first step that we need to do before we can complete the square is we've got to get all of the variable terms over to one side. We're going to put all the variables over here on the left side of the equal sign. And we're going to take all the constant terms, we're going to move those over to the right-hand side, okay, before we can actually complete this square. I'm going to essentially put this thing in standard form, except taking the constants and putting them over on the right-hand side. So if I want to move this 2x to the left-hand side, I'm going to subtract it. So that's going to be my first step. I'm going to subtract 2x on both sides. So that's going to give us x squared minus 2x plus 7 is equal to 8. All right, so it's starting to look a little more familiar. All right, like I said, I'm going to take the constant terms now and I'm going to move those over to the right-hand side. So this positive 7, I'm going to move to the right by subtracting. So that's going to give us x squared minus 2x equals 8 minus 7 is 1. Okay? So that was essentially step 1 from the previous example. So where we were isolating the variable terms, all right? So we got those all over here on the left-hand side together. Okay, then we go to step 2, which is the step where we're actually completing the square, all right? So I'm going to have, remember I'm going to do those little, do the little blanks. So we got x squared minus 2x plus something is equal to 1 plus something, all right? I'm going to come over here to the side and I'm going to do that part where we actually complete the square. Okay, so I gave you a little formula, b divided by 2 squared, and that's going to allow us to make a perfect square trinomial over here on the left-hand side. So in this quadratic, our b is negative 2. I'm going to plug in negative 2 divided by 2, and then I'm going to square it. So negative 2 divided by 2 is negative 1, and negative 1 squared is positive 1. So I'm going to put plus 1 in the blank on the left-hand side. I made a perfect square trinomial right here. And what I do to one side, I also have to do to the other. So I'm going to add 1 on the right-hand side as well, excuse me. All right, so I made a perfect square trinomial. Think about it, factors of 1 that add up to negative 2. Can you think of factors of 1 that add up to negative 2? Well, negative 1 and negative 1, right? So if you wrote those as 2 binomials, it would say you'd have x minus 1 times x minus 1 equals 1 plus 1 gives us 2. All right, now because these 2 binomials are the same, we can write them as a binomial squared. In fact, we'll get to the point where we don't even write the 2 binomials out. We go straight to the binomial squared. So x minus 1 squared is equal to 2. X minus 1 squared is equal to 2, okay? Again, at this point, this looks similar to what we were working on last week, where we were using the square root method in order to solve. So I want to get x by itself. The first thing I need to do is take the square root of both sides to get rid of the square. So I'm going to take the square root of both sides. That's going to give us x minus 1 equals, remember your plus or minus, the square root of 2. Now square root of 2 is not a perfect square. So we're going to leave 2 underneath the radical like so. All right? The next thing we need to do is we need to move this negative 1 over to the other side. Well, we would do that by adding 1 to both sides. I think we can do that part in our head. I'm going to add 1 to both sides. So that's going to give us x equals 1 plus or minus the square root of 2. Okay? Now, how many solutions is that, or how many zeros are there of the functional? In this case, there are 2. That means this quadratic crosses the x-axis in 2 places. The first place it crosses is at 1 plus the square root of 2. The other one is at 1 minus the square root of 2. Now you can actually, put this in a calculator and work out these solutions and get some actual answers here. This one would be about 2.4, somewhere right in there, okay? And you can plug those in and get some approximations of where they're going to cross. All right, they're not pretty whole numbers on this one. Nonetheless, there you go. That is problem B. So now what I want you to do is I want you to try problem A. So it looks like this. It's got x squared minus 8x plus 3 is equal to 11. Try it on your own and then watch the next video.